Good morning. Good morning. Hope all is well. Hope everyone's doing all right. Still got people trying to trickle on in, so give them a chance. All right. So, like I said, I hope everybody's doing good. We are gonna get into 3.7, not 3.6, 3.6, 3.6 today. So let's go ahead and get that out the way and go from there. Try to get this weekend started. Let's see. All the way up. All right, so last class, we knocked out 3.5. Today we'll look into 3.6 and go from there. So 3.6 is polynomial and rational inequalities. So before we've had polynomial equations, rational equations. This time we're dealing with inequalities. You know, our inequalities come from greater than, less than, greater than, equal to, less than, equal to. So we'll talk about using those symbols. First type that we'll look at is your quadratic inequality. Instead of a quadratic equation, we now have a quadratic inequality. And, you know, whenever we have a quadratic equation or a graph or expression, you know, that gives us a parabola. You know, concave up, we talked about being concave up versus concave down. Concave up gives us a U shape. Concave down is upside down U. So notice what happens here. When you look at this U, we have these points where our graph, you know, is equal to 0. You know, that's why our parabola is equal to 0. So the intervals that are created by that interval, by those points, notice everything above the x-axis would be positive results. Everything below would be negative, and everything above is positive. So it creates this alternating positive, negative, positive. Or if it's upside down, it's negative, positive, negative. So when we plug in values, those will be the results that we'll get. And so we're going to see that when we go about solving these equations and why that's important. But notice when we do these quadratic, it's either going to be positive, negative, positive, or negative, positive, negative. And like I said, you'll see why that matters in a second. All right. So let's say if we look at 2x squared plus x greater than 15. First thing you want to do is set one side equal to 0. And we can do that by subtracting 15 from both sides, giving us 2x squared plus x minus 15 is greater than 0.
Is that greater than symbol supposed to have the parentheses? Is that why you have that circled up there?
Yeah, it's going to connect when we go down further. Yep. All right, let's scroll up. So now we have 2x squared plus x minus 15 is greater than 0. So the reason why we set it equal to 0 is so that we can compare the expression to 0, because something being greater than 0 is positive, something being less than 0 is negative. So basically, we're just asking ourselves, when is this expression positive? In other words, if it's greater than 0, you want to know when is it positive. All right. So now we're going to solve for when the equation is equal to 0. So don't forget there were those 2 points that we're looking for. That's going to help us to set up our intervals. So in order for us to find that, we want to figure out when is it equal to 0. We're going to come back to being greater than 0. But right now we want to know when is it equal to 0. So we can find those 2 points. So you just solve your equation the way you normally would. 2x squared plus x minus 15 equal to 0. I decided to go ahead and factor. And factoring suddenly those factors equal to 0 gives us 5/2 and -3. All right, scrolling up. So those 2 points help us to set up our interval. And so just a generic number line showing you how this thing will work. Notice our interval is going from -infinity to -3, -3 to 5/2, then 5/2 to infinity.
Shouldn't the 5/2 be negative, or why is it not negative?
When you solve, you add 5 to both sides and then divide by 2. So hopefully that's what you were talking about, just making sure. So now we're going to set up a chart. Now, some people choose not to set up a chart. I think it's best to set up a chart, help you to, easily see what your answers will be and all the good stuff like that. But if you decide not to, you just, do what you do, then that's fine. You still have to go through the process, right? So see, our first row is our intervals. Second row will be test values. Third row will be the behavior of the graph. All right. So we already established our intervals: -infinity to -3, -3 to 5/2, 5/2 to infinity. So before you go further, though, you do want to establish what you should have as far as parentheses versus brackets. And remember, going back to what we've done before with interval notation, parentheses, your infinity sign will always carry, will always be attached to parentheses. The other numbers will be dictated according to this symbol right here. It's like Mr. Williams asked why I put that. That goes back, that's where, excuse me, if I can get my throat clear. That goes to the parentheses. So whenever you see just the greater than, now if it was greater than or equal to, then we would be looking to use bracket. So I'm going to use parentheses on all of my signs, all of my numbers, excuse me. Any problems with that before we go to the next row?
Can you show it if there was a greater than or equal to sign real quick, just to show like where the brackets would go?
Oh, everything that's not a parentheses. So it would be
inside of the infinity sign would be a bracket then.
Right. I said everything not parentheses. Everything that's not infinity sign, right, would be a bracket. Mm-hmm. All right. So now test values. You want to choose a number that's going to be in the intervals that you have presented before you. Now remember, everything responds the same way within those intervals. So it doesn't matter what you choose, as long as you choose the same, choose a value within the interval, it will still either give you a positive result, like these two will, or it will give you a negative result. So it depends on whether it's concave up, concave down, or whatever. But just choose a value that's less than -3. I chose -4. You could choose -100. The bottom line is that it's going to give you either a positive or a negative result, because everything in this interval responds the same way. everything in this interval is going to respond the same way. I like to choose 0 when I can. So I choose 0, that's in between -3 and 5/2. And then once again, everything in this interval will respond on the same way. So I'll choose something greater than 5/2. And I believe I chose +4. I'm just talking about according to my notes. But you can choose anything. If you want to put 1 million right there, it's still going to either give you a positive or negative number. That's what we're looking for. And that if it produces a positive number, that means 4 will produce a positive number. So all of the numbers in that interval produce the same type of number. In other words, same behavior in your graph. Once you establish what your test values are, and once again, make sure they are in there, because if you don't choose a value that's in there, you're going to get a different, the opposite result. You plug them in. I normally plug in into what I factored, but if you decide to use your original equation, it's still the same thing. But a lot of times I'm doing stuff on the board, so I do it the easiest way possible. So plugging in -4. If you want to get the actual answer, fine. But you just need to know, is the number positive or negative? So when I plug in -4, this parentheses gives me a negative result. This parentheses gives me a negative result. Negative times negative is positive. So that's what I'm looking to have right here. Anything in that interval will produce a positive number. And so somebody asked about it earlier. So, that first parentheses gives you -13. Second parentheses gives you -1. Multiply those together, you get a +13. The fact that it's a +13 is cool. I just need to know that it's positive. Plugging in 0, you get a negative result. Plugging in +4, you get a positive result. So like I said, when it comes to the behavior of the graph, you just need to know, is it positive or is it negative? -2, Mr. Bracy asked, what will happen if you put a -2 in there? If you put a -2 in there, you still should get a negative number. He said in the middle value. So if you put a -2 in there, -2 times 2 is -4. -5 is -9, excuse me. And then -2, let me show you. So if I put a -2 in right here, that would be a -9. And then I would have I have a +1 right here. And so my result would be -9, which is still a negative number. And so that would be something that would be in that interval right there. So no matter what you choose, it will still give you something in that interval. And that interval will produce a negative in this case. So it is still fit.
So those negatives and positives at the end, those are done by solving each interval individually and then coming up with whether the answer is positive or negative.
Yes.
Okay.
All right. So once you've done that, now we can go ahead and figure out what our answer is. Once your chart is filled out, go back to your original expression. We want to know, when is this greater than 0? In other words, when is it positive? So now, when is it positive? Oh no, have my eraser still on? Come back, there we go. It's positive here and here. So those are the intervals. That would be my answer. So that's why we set one side equal to 0, so we can have a clean comparison. You want to know, when is our expression greater than 0, or it will be when is our expression less than 0. If it's greater than 0, we're looking for the positive results or the positive behaviors. If it's less than 0, then we're looking for the negative behaviors. All right, yeah, right. Any questions with what we done up to this one? Now, this one, this is the foundation of what we're gonna do. This is the exact same thing we're gonna do for every single problem in this section. You know, you find your spots where your function is equal to 0. That sets up your intervals. Choose your test value. Of course, establish parentheses and brackets and stuff. Test values, plug them in, figure out where it's positive and negative, and then from there you'll be able to find your answer. So this is the process for each problem that we do in this section.
So in math lab, is it going to want us to find the behavior and answer the behavior as well before it comes down to ask for the interval notion? Or
No, it's not
is
going to ask. It's not going to ask for none of that work. It's just going to ask for that right
you got
there.
this interval notion way before you did any of the test values?
You
Like, so you
say,
have all of it right there. All you have to do is essentially remove the middle one, put your and symbol or
Mhm.
symbol, and you have the answer without doing any of that.
well, how did you know which one was going to be your answer?
So, right, well, at the end, you have interval notion written out. Well, you have the interval notion written out right here, up right above
Tell me this right here.
yeah. So all you have
Right.
to, if that's the answer, that's what I'm saying. You remove the middle interval notion, just put that and or symbol, and then that would be the answer, correct?
Oh, no. Because what if let's say if it was less than, then it would have just been the middle. You see what I
Oh,
mean?
okay.
Yeah,
Okay.
that's why we had to go back to this
Okay.
right here. Uh-huh.
Okay. Okay. So if they all would have been positive, then we would have to put all of them up there.
Yeah, if you were for abstract example, yes. But it would never all be positive. But
Right.
yes, if you just you would all would have been answered. Yeah.
I'm following. So on the ones where it's negative, then you just have to provide the negative one.
Right. Yeah.
Okay.
And there's no guarantee whether it's going to be positive, positive, or negative, positive, negative. And that's why you go through the process. And then that'll determine whether you have just one parentheses or both parentheses. Yep. All right. Let's try it again. I wish it was that simple, man.
I was like, man, if this ain't some busy work.
So next one right here. X cubed plus x squared less than or equal to 4x plus 4. So once again, we want to set one side equal to 0. This time we have a cubic equation, but we still want to set one side equal to 0 so we can make that clean comparison to 0. And this time it'll be less than 0. So we want to know when is it negative. So you have x cubed plus x squared minus 4x minus 4 less than or equal to 0. All right, scrolling up some. So just like before, once you set one side equal to 0, go ahead and set your equation equal to 0 and go ahead and solve. So because we have 4 terms here, we need to go ahead and factor by grouping. Group together the first 2 and second 2. In the first parentheses, pulled out x squared, second parentheses, pulled out negative 4. Brought x plus 1 to the front because that's what they had in common. That left me with x squared minus 4 in the parentheses. X squared minus 4 is the difference of squares. So it's x plus 2x minus 2. Then you set each piece equal to 0 and solve. So this time we have 3 values in which gives us 0 for our equation. All right, so here are our intervals, -2, -1, 2. And this time, because it's or equal to, we're going to use brackets here instead of parentheses. Now, parentheses will always be on your infinity signs, but we have brackets on our -1, -2, and 2. I was going to erase, but I'll leave those there. We'll still walk through it though. All right, so see the order pairs, not order pairs, the test values that I chose. Our first interval is from -infinity to -2. So I chose something less than -2. That would be -3. Then we have -2 to -1. So it chose something in between those two values, -1.5. Something in between -1 and 2 would be 0. Something greater than 2 would be 3. All right, kind of scroll up. Once again, I like to use the factored, representation of that expression. So I plug my -3, -1.5, 0, and 3 into that expression with the factors. So plugging in -3, I ended up getting a negative times a negative times a negative, which ends up being negative. Plugging in -1.5, negative times positive times negative, which ends up giving us positive. Plugging in 0 gives me a negative result, and plugging in 3 gives us a positive result. All right, somebody asked me to scroll up a bit. I don't know how far you want or how much a bit is. Okay, cool. So getting ready to finish this up. So don't forget we had less than or equal to. So this time we're choosing the negative intervals. And had a classmate that was looking at something up there. So before I scroll down for the answer, see our two answers would actually be, the intervals where we have our negative responses or negative behaviors.
So if this symbol would have been greater than or equal to,
Mhm.
would we still be looking for when is it positive again?
Yes.
Okay.
Yep. So it would be the other two answers versus the ones I circled. Yep. T-Rex, that's how you do it. All you do is plug in the value from each interval. Once again, those intervals, they could have been any number as long as they're in those intervals, and then see the behavior. And then that behavior lets you know what the answer is according to your, what's the name of it? Inequality, according to the inequality. Yeah.
All right, I'm gonna
Why
be.
is that?
I'm completely lost on everything. I have absolutely. I'm writing everything down.
Mhm.
I'm gonna need to go over everything in the office hours because I'm like totally clueless. I
All
don't
right.
get.
All right.
Why is that one negative in the answer?
You said that one is negative, and the answer, so right here,
Yep.
goes back to right here. Remember we had negative ones. Careful right here.
Oh yeah, I missed. Yeah, that's my bad.
Okay, cool. All right. Anything else before we do another one? Yep, you always want to compare it to zero. So you're always going to be doing greater than zero or less than zero. That allows us to stick to the idea we're talking about positive here versus negative here. So that's why you always have to set one side to zero. Okay. All right, so let's look at the next one. Rational inequalities, we're gonna keep with the same steps, same flow. Except this time we have a numerator and denominator. So instead of finding those factors that we just found, we're going to set the numerator equal to 0 and the denominator equal to 0. All right, set a numerator equal to 0 gives us -3. Setting our denominator equal to 0 gives us 7. And that's how we will establish our interval this time. All right. So once you have your values, you can go ahead and establish your intervals. We use parentheses here because it's just less than. So use parentheses for everything. And then test values. I chose -4 because that's less than -3. 0 because that's in between -3 and 7. And then something greater than 7, I used 8. All right. Very good. What we done? So our expression x plus 3 over x minus 7, plug in -4, plug in 0, plug in 8, see if we get a positive or negative behavior from our graph. Plugging in -4 gives us a positive result. Plugging in 0 ends up giving us a negative number. Plugging in 8 gives us a positive. And we want it less than. So our middle one fits that description of negative. So that's our answer. Questions? Any questions? We got at least one more. Still see writings. All right, good to go to the next one. Good. All right. So the next one is this. We have x plus 1 over 3 over x plus 3 is greater than or equal to 2. And just like before, we want to set one side equal to 0. And the last one we just did, we didn't have anything on the other side but 0, so we didn't come across this issue. But here we have 2, and we want to set that right side equal to 0 by subtracting 2 from both sides. Now we have to be careful here because we have a fraction. In order to add or subtract fractions, we need a common denominator. So 2 is 2 over 1. We needed to have a denominator of x plus 3, so I multiply top and bottom by x plus 3. Yep, still have my wrist on. So that's what happens here. Now I decided to bring them together just to emphasize this distribution of this negative. So be careful right here because a lot of times this negative does not get distributed to each term in that following parentheses or in that following numerator. So make sure you're careful that you distribute the negative with each term or into each term of that following numerator. So notice I distributed -2, not just 2. And so that gives us x plus 1 minus 2x minus 6. Combining your like terms, that's -x minus 5 over x plus 3.
Could you go back over how you got the x plus 3 in there?
That came from here. So yeah, it just depends. If this denominator is x plus 5, then I would have been multiplying top and bottom by x plus 5.
Okay.
Yeah. Just like if you had the fraction 1/3 plus 2. Well, in order to add those together, you need to multiply top and bottom by 3 to have a common denominator. So it's the same thought
I see.
process. Say it again.
I see.
Oh, okay. Okay. Cool. All right. So then we put it back. Remember, our relationship was greater than or equal to 0. So we have negative x minus 5 over x plus 3 greater than or equal to 0. I got a lot of little bubbles and stuff going on. I was going to erase stuff, but I'm going to end up putting it back. So I'll just leave it and we'll talk about it when we get down there. But so we should have minus or negative x minus 5 over x plus 3 greater than or equal to 0. All right, can I scroll up? All right, so we have our solid rational expression. We have a top and bottom set each part equal to 0 like we did in the previous. So negative x minus 5 equals 0, x plus 3 equal to 0. Solve those. X is equal to negative 5. X is equal to negative 3 for when this expression is equal to 0. All right, can I scroll up some? Talk about what all these bubbles mean. All right, so let me do this. So the first thing you want to do is establish your intervals, and we see that we have negative infinity to negative 5, negative 5 to negative 3, and then negative 3 to positive infinity. So we have our intervals established. Now the thing that we have to be careful here is with these parentheses versus brackets. Your infinity signs will always have parentheses. Now we have greater than or equal to here, so we know we have to use bracket, but we have to be careful because bracket means that you're going to include it. See, not sure what you mean, Mr. Bracy, but brackets mean that you will include the value. Now, don't forget we have a denominator here in which we have negative 3, but when I plug in negative 3 into the denominator, I'll get 0, but I cannot have 0 in my denominator, right? So don't forget that element of having a fraction, you cannot have 0 in your denominator. So that means I cannot use negative 3 as a part of my solution set, but bracket means you will use it. So what we would do is use bracket on the negative 5 and then parentheses on this negative 3 because that's coming out of the denominator of when your denominator is equal to 0. Right, yep. Right, Mr. Brayson, you got it. So you do have to be careful when you're dealing with these rational expressions and you have this or equal to symbol. You can use bracket on the number that's coming out of the numerator, but you still have to use parentheses on the one coming out of the denominator. And for some of you who've been emailing me, you do know that my math lab will mark it wrong if you're supposed to get a bracket and you use parentheses instead. So yeah, it'll get you. So make sure you pay attention to those. And the last one, we didn't come across this issue because we had parentheses. We had it was just less than symbol. So we didn't have to worry about brackets. So it only comes in play when we have the or equal to symbol dealing with these rational expressions. Any questions on that before we move forward? All right. So from that point, everything else is going to be the same. You're going to establish your test values, plug them in, then find your behavior. And then from your behavior, you look and see what matches up with the symbol that we're using. So I chose -6, -4, and 0. Those are values that are in these intervals. If you choose something that's not in the interval, then you will get something different, but you just need to choose a value that's in the intervals. If you do that, you'll still get these same behaviors. So plugging in -6, ended up getting a negative number. Plugging in -4, you get a positive number. See if I can get 0 in there. Yep. Plugging in 0, you'll end up getting a negative number. So we want to know when is it greater than or equal to 0? And that would be for that middle interval of -5 to -3. Questions? Any questions? Okay, so the question says, how can -3 be greater than 0? So it's not about -3 being greater than 0. It's when you plug in -3, what comes out. So -3 represents your x values. That's what you're plugging in. But what about your y values? So when you plug in -3, now in this case though, -3 is when it's undefined. If you plug -3 into this function, you plug in -3 right here, you get 0 in your denominator. But these other values that are in between -3 and -5, that's why we use parentheses on the -3. That means you can get as close to -3 as possible. Cannot use -3. But the values in between -3 and -5, when you plug them into this expression right here, you'll get a positive value. So case in point is right here. If you plug in -4, if you would actually do all the work, so that's going to be a +4 minus 5, which is -1. And then that'll be a -1, and that'll be a +1. So you end up getting a +1 out. So you plug in -4, get a +1 out. Mhm. Any other questions?
Yeah, just one more time. Can you walk through the parentheses and bracket on the greater than or equal to and how you deciphered those again?
All right. So that we have to use brackets because it says or equal to. All right. Now, the only ones that are up for getting brackets is at the -5 and at these 3s, right? So you're going to put a bracket there or not. So whatever value that comes out of the denominator, you cannot put a bracket there, which is this value right here. Cannot put a bracket there because when I plug that into the equation, I actually get 0 in my denominator. Now, bracket means you can use that value. Parentheses means you cannot use that value. And so that's why this value that comes out of the denominator is the one that get parentheses, because I cannot use that value, because when I do use it, I get 0 in my denominator. The numerator one is fine. Having 0 in your numerator is fine. It's the one that comes out of the denominator that catches parentheses.
So the only numbers available for the brackets are the actual numbers from the original equation.
Oh yeah. Uh-huh.
Okay.
All right. Any other questions on anything that we've done? All right. So those are all your scenarios that you will run across in this section. Not going to go into a new section. We'll use, as a matter of fact, there's only one more section left out of chapter 3. And, we can save that for next class. Any other concerns or questions about what we did today before I close out? Everybody good? I guess, Don, I'll either see you Wednesday or Friday.
Does
So,
this cover both the sections in my math lab? Because 3.6 has 2 parts in my math lab.
Yeah, that's what I was going to ask.
let me check it out real quick.
See, I'm caught up, so I know these things now.
Let's see. It's probably broken up into the first part being your polynomials, the first 2 problems that we did, and then the second part being irrational, which is the last 2 problems that we did. Oh, come on, man. Yep, that's how it's broken up. So the first 2 problems applies to that part A, and then the second 2 problems applies to part B. All right. So somebody said, let's see. So we didn't need brackets in the first one because it was just parentheses. It just asked for parentheses. The brackets didn't come up in that first one that we did. That's why all of it was parentheses.
I have 2 questions. So for on Math Lab, we don't do 3.2.
No, unless we double back, unless I decide to go back. No, you don't have to.
Okay. And also, I sent you an email yesterday about I think what's it called, refreshing my chapter 2 test so I can take it a 3rd time.
Okay. Yeah, I'll get to it probably today.
Okay.
I probably just haven't got a chance to get to that one. Yep. So I'll probably get to it today, and yeah, that's not a problem. All right. Anybody else before we close? I see stuff in the chat. So brackets, no. Or the first or the last 2. Why do we take the negative instead of the positives? That depends on if this is less than 0, that means negative. And if it's greater than, then that means positive. So that's what dictates that. All right. Not a problem.
I have one question, but it's about 3.5. So I can wait till everybody dips real quick if you want.
Okay, I got somebody, Ms. Newman. She has a question as well. So if you want to stay back for these questions, then feel free, but if not, you are dismissed. And I will see you on next class. Have a great weekend.
You too. Bye.
Thank you. Have a good one. All right, Ms. Newman, you said you had a question?
Hey, yeah, how are you?
I'm good. How about you?
Pretty good. I'm trying to get caught up. I had all of my tests this week for history, business, English, and math all due this week. I believe that I have 4 homework, like 2 or 3 homework assignments, and I was wondering if possible that I could get the test pushed to Friday so that I can finish all of those assignments tonight. My business class is over, so now I can focus more time on my calculus.
Yeah, all I ask is that you send me an email to remind me, and I'll make
Okay.
that adjustment. It's not a big deal.
Okay, and then I should be able to start getting caught back up and be to where y'all are.
Okay,
I'm
not a
trying.
problem.
All right, thank you. That's all I had to ask. Thank you
Okay.
so much.
All right, not a problem. All right,
Have a good day.
you do the same. All right, what you got, Ms. Williams?
All right. So when it's excuse me, it's reading the vertical isotopes when it gives you the graph, and it's like as x is -3, f of x is. So obviously, the way these graphs are drawn out, it's going to be infinity or negative infinity. The problem is, I don't know which way I'm supposed to read the graph. I'm reading it left to right, top to bottom, because there's vertical isotopes on each side, on the negative and the positive side. And
Which
obviously, so on section 3.5, it was questions like 4 and 5.
okay.
If you just want to like pull those up.
Yeah, that's what I'm trying to do now. Pull it up for you. Said 4 and 5. You said 4 and 5?
Yeah. It's where they give you a graph. And
Okay,
they want
5.
you,
Okay. Yeah. I see it.
And I see the isotopes.
Okay. So now they didn't have one of these in the examples in the, in the book, So to see, this is actually something that they do from calculus. See how they had this minus sign on the right side of your 4? So this says you go towards x, go towards -4. It says x goes towards -4 from the left side. And so that's what that means. So -4 is right here. If you're coming from the left side, it's going up. So it should be positive infinity.
Yeah. Okay.
Yeah.
Because
So
I got it through the example. Because the example was similar, but I still just like it wasn't click. I'm like, how am I reading this graph? Because then you see the other ones, because the next question ended up same type of question, but ended up being negative infinity.
yeah.
And I'm just like, how in the world?
And see, if this was positive on the right, it would be coming from the right side, and then that would have been negative infinity.
So the negative sign behind the number dictates which way you read the graph.
Right. Well, it
X.
dictates which way you're coming from, approaching that number. So if this is -4, and if it's minus sign on the right side, that means I'm coming from the left side. But if it has a positive sign on the right side, that means I'm coming from the right side.
So it could still be -4 and then have a positive sign on it, but you're going to come the opposite direction towards it.
Exactly. So,
okay.
Just to reemphasize, -4 is right here. You're going to be approaching, this means left side
Strong
of
side.
-4. So you're going to come this way and follow the graph, and that gives you negative infinity. I'm not drawing the graph that was up there. I'm just
No, yeah. That
abstract.
makes sense.
And then if it said this, and this means right side, if I can spell right, the right side, and so that means I would be coming this way, following the graph, and that would give me positive infinity.
That makes a lot more sense.
And see, they didn't put an example like that, in the examples that I ran through. So I didn't know, but that's actually calculus. That's something that
Trust me, I know it didn't put an example in there because I was fumbling through my notes. I'm like, I don't remember seeing this. What is this? Like, come on.
right.
So hold on though. On the positive one, so it says -4 with the little positive sign on the right. And you came from the right. I get that part. But why would you go up if it's -4? Wouldn't you go down?
You got to follow the graph. So my graph was doing this. So you just follow your graph. Whatever your graph is doing, that's what you give. So it's going up.
Okay.
And so here, my graph is going down. So I just follow my graph down, and that's negative infinity.
Okay.
Yeah. All right. So
cool.
All right, sir. I'm glad I could help. Don, you coming today or Saturday, Friday?
Well, I tried coming last time, but I waited for a little bit and then I had stuff I had to do and I was like, you know what, let me just take care of this stuff. I had already finished the homework and it was just stuff I needed to clarify. Like I do have like 7 questions I needed to clarify on the homework, but I did finish it and I got like an 86. So I was like, well, that's 100. So whatever.
see, Brandy, we messed her up, man. We did.
I told you, bro. We shouldn't have done it. Shouldn't have done
She
it.
tapping out. She tapping out too quick now.
So I
Like
don't know.
that benchmark dropped a little bit.
Yeah.
Yeah, my brain is like it's melting. I don't this entire class, and it seems super simple, but I
will
don't
tell you,
understand
like,
any
Dawn,
of it.
You I think you're overthinking today. Today is gonna
I
like
think
when you
so.
go
It just
through.
feels like it.
Yeah.
And so I just wrote everything down, and I was like, you know what, I'm gonna have to go over it slow with you today because I think I am overthinking it. It looks real simple.
It's a lot more writing than you think it is, but
Yeah.
it's a lot more simple when you just
Yeah.
figure out what you're trying to get to. And once you because I think you're where I was, like you're so scatterbrained everywhere else, you can't really focus on the here and
Real,
now.
I'm all jittery and like hyped up right now. I can't.
We gotta get you to decaf, yo.
Real, I shouldn't have gotten that extra shot in my Starbucks this morning.
Over here, like shaking that she's
I'm
writing her
like,
math, her negatives and positives and stuff.
Yeah, I'm gonna be there today for sure.
All right. Okay. Well, I will see y'all in a few then. And
All right.
y'all have a good one. I'll go ahead and run to this next class.
All right, man.
Thank
Appreciate it.
you.
Y'all
Have a
be
good
good.
one.
All right. Take care.
Later.